Okay, so I had a student ask the question, how do we do addition in multiple octets? Or subtraction in multiple octets. So let's go ahead and count in binary again. We've already done it before. We have our 1, we have our 2. When there's 1 in both spots, that's 3, and so forth. So what happens when we get to the point where it's 5, 6, 7, 8? So what number does this equal? This is missing the 2 and the 1. So this should equal 252. So what's 253? And that is what about 254? What about 255? One, two, three, four, 5, 6, 7, 8. How do we get to 256? Remember, in networking, we do everything in groups of 8. So if we want to go to 256, we add one more to this, but we can't. All of these become zeros. And we go to the next octet. What about 257? What about 258? 0, 0, 0, 0, 0, 0, 0, 0, and so forth. Because here, there's still the third octet. It's just right now, these are all zeros. So we just omit them. But they are still there. We just omit them. Because when we're only dealing with smaller numbers, we don't have to get tied down to all the additional zeros. So, how do we go from 258 to 257? Well, again, 258 is 1, 1. And to go down, we just subtract 1 bit. We can't subtract any of the ones from here. We have to go to the next octet. Four, 5, 6, 7, 8. What happens if we want to go to 256? Again, we can't subtract from these zeros, so we have to take the 1 from here. This is in the 2 spot, so that becomes 0, it becomes 1. That's 256. What about going to the 255 position? Here, this is going to change from 256. We're going to borrow the 1. And all of these become 1 then. Get all of these, when you add them up, should equal 255. If we subtract 1 more, we go to 254. One, 2, 3, and we just keep counting down. If all else fails, you can always convert them back to decimal and do your subtraction, and then reconvert them to binary. But I wanted to show people this because this going between the 2 different octets, between 3 and 4, is really confusing for most people. So I wanted to show you how the math is done. Thank you.